So I am going to rub. Have you copied it?
Yes, sir.
Okay, that's good. Now go to question number 2 of 9. That is f of a square plus 1. Can you please let me know what will be the value f of a square plus 1? For x it will be, you see, for x it will be a square plus 1. This is minus 1. So we are getting root over a square. It is also only a. Okay. Now you see number 3. If fx equals to 5, f of x equals to 5. Very good. And it is given that f of x is equal to root over x minus 1. You see, we have got the same left hand side. Left hand sides are same. Okay. So what is meant by this? Their right hand sides will be equal. Therefore, we can write down from these two, we can write down root over x minus 1 is equal to 5. So if I square both the sides, then we will get x minus 1 equals to 25, right? That is x equals to 26. Math is done. Okay. So we are getting the value of x as by 26. Now, number 4, fx equals to y. So fx equals to this and fx equals to y. So what we are getting, x minus 1 equals to y. Okay. Here we have also to find the value of x. So what can we do? X minus 1 equals to y square by squaring. Okay. So x equals to what? Y square plus 1. Is it okay? It is really very, very easy and simple math. But this math is given in the exam. Now, now the maths of one function. One function. One function. And one to function. One to function. Okay. One function and one to function. Okay. So that they told you what is one function. One function means what? For, write down, for a certain value of x, there will be a certain value of y. This is called one function. Okay. You see, for a certain value of x, there will be a certain value of y. One for one. One function means what? One for one. So now we will do some maths on one function. You see, suppose a function is given, fx is 2x plus 1. The question is, it is a one-on function or not? Okay, it is a one-on function or not? You see what is to do? Write down. At first, write down for x belongs to R. Okay, fx exists. Therefore, DOMAP equals to R. This is our first condition. Okay. That day I told you how to find the domain of a function. There, I gave you some embargo for a fraction and a square root. If there is any square root or there is any fraction, then you have to think to find the domain of the function. So what I have written here, for any x belongs to R, fx exists. Yes. Suppose you can let any value of x and you will get the value of fx. Now you write down for any x1 belongs to a domain. This is the format to do all maths of on function. For any x1 belongs to domain, x2 belongs to domain. Okay. F of x1 equals to f of x2. Okay. If and only if and this is known as if and only if f of x1 equals to f of x2. You see, it is fx. So if it is in x1, so it will be what? 2x1 plus 1 equals to 2x2 plus 1. That means x1 equals to x2. Okay. So we are getting therefore fx is a one function. You see, we have got x1 equals to we have got x1 equals to x2. It is not that we have got x1 equals to x2 plus 1 and again x1 equals to x2 plus 5. We have not got like this. If we would get like this, then it would not be a one-on function. Please try to understand. Okay, we have got only one value of x1. Okay, you understand? And here x1 and x2 are not equal, suppose, but we have got that they are equal. So this is the way how we can do any math. Suppose I am giving you another example of one. It was number one of one function. I am going to do some maths of one function. Suppose you see fx equals to x square. This is number two of one function. Can you please let me know what is to do? You write down the same thing for any x belongs to R, fx exists. Yes, you can let any value of x, you will get a value. So domain equals to here also R. So all are same, the difference is here. You see, all are same, only the difference is here. You write down everything. Fx1 equals to fx2. Fx1, that means what? Implies that x1 whole square is equal to x2 whole square. Okay. Fx1, so x1 whole square equals to x2 whole square. X1, so it is x1, it is x1. So we can write here x1 equals to plus minus x2. So here we are getting two values of x1. One of them is x1 equals to x2 and the another value is x1 equals to minus x2. You see they are same, but they are not same. Okay, you understand? So it is not a one function. Write down, therefore, fx is not a one function. Have you got it? You please try to understand. So here fx is not a one function. To determine a function, whether it is one or not, it is the procedure, and you have to maintain the procedure. Okay, I think you have copied it. Number 3, suppose fx is equal to x by x minus 1. You have to determine whether this function is on or not. At first, what I told you, can you please tell me what I told you? Before determining on function, you have to verify whether it is, you have to find out the domain of the function. Write down it belongs to R if and only if the denominator x minus 1 is not equal to 0, that I told you, or x is not equal to 1. So what is domain? Let me know. What is the dome of the function? Domain of the function. All real number other than 1. This is
1.
the, yes, so this is the domain of the function. Now you write down for any x1 belongs to domain, x2 belongs to domain, fx1 equals to fx2 if and only if. Okay, now you put the value here. Here you have to put the value x1 by x1 minus 1, x2 by x2 minus 1. Okay, I think what I have done, you see here x1, 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 here x2, 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 x2. Left hand side is of x1 and right hand side is of x2. Okay, now we multiply. If we multiply, we will get, implies that x1, x2 minus x1 is equal to x1, x2 minus x2. And you see from both the sides, these and these are omitted. So we are getting minus x1 equals to minus x2. That means x1 equals to x2. You see, x1 and x2 are equal. So as they are equal, so fx1 and fx2 was equal and it was left. Therefore, fx is a 1 function, 1 for 1. For x1, it is x2, 1 for 1. So we have got the given function as a 1 function. Okay. Now, suppose another math is given. This is number 4. Fx is equal to 2x by 3x minus 5. Now, you have to determine whether this given function is a 1 function or not. Can you do this math, please? Let me know. What is to do? It belongs to R if and only if 3x minus 5 is not equal to 0. Okay, a condition on the denominator for a fraction. Okay, that is we are getting here x is not equal to 5 by 3. Therefore, DOMAP is equal to R difference 5 by 3. Okay, If you don't show this part, your 2 marks will be deducted. So what should be written now? For any x1 belongs to DOMF, x2 belongs to DOMF, fx1 goes to fx2, if and only if. Now do. For x1 you write down 2x1, 2x1 by 3x1 minus 5 is equal to 2x2 by 3x2 minus 5. Okay, what I have done here, you see, it is 2x, so it will be 2x1, 3x, 3x1. It is 2x2, it is 3x2, it is fx1, it is fx2. Okay, now you just get it just as the cross multiplication. That means we are getting here 6 x1 x2 minus 5 to the 10 x2 is equal to 3 to the 6 x1 x2 minus 10 x2. From here we are getting this cancelled. So minus 10 x2 equals to, and sorry here, minus 10, it is x1. It is x1, huh? Make the correction. It is x1. So it will be x1 equals to minus 10 x2. Minus 10 will be omitted. So we are left with x1 equals to x2. Therefore, fx is a 1, 1 function. Okay, have you got it?
Sir, done. Yes, sir.
Okay. Now, another math number 5. Fx equals to x minus 1 by x minus 2. Okay, you have to show that whether, you have to determine whether the given function is a one-on function or not. So what will you do? You have to write down belongs to R. Okay, if and only if the denominator x minus 2 is not equal to 0. That is x minus 2 is not equal to 0. So we are getting, oh, I have written that, sorry, I have written that. That is x is not equal to 2. From here we can find. So DOMF equals to what? Therefore, all real number except 2, right? All real number but not 2. Is it okay? So you write down for any x1 belongs to DOMF, x2 belongs to DOMF, if x1 is equal to f x2, if and only if you put the value here, we are getting x1 minus 1 by x1 minus 2 is equal to x2 minus 1 by x2 minus 2. Okay, this is the left hand side and this is the right hand side. It is of x1 and it is of x2. Now you just multiply. Okay, then we can write down x1 x2 minus 2x1 minus x2 plus 2 is equal to x1 x2 minus x1 x1 x2 minus x1 minus 2x2 plus 2. Okay, so actually what is happening here, you see what is happening here. We are getting this part and this part cancelled. We are getting this part and this part as cancelled. Okay, that is minus 2x1 minus x2 is equal to minus x1 minus 2x2. What is happening here? Minus 2x1 plus x1 is equal to minus 2x2 plus x2. So here minus x1 minus x2, that is x1 equals to x2. So we have come to conclude that yes, fx is a one-on function, is a one-on function. Okay, have got it?
Yes, sir.
Suppose number 6, perhaps fx is 2x minus 1 whole square. Determine whether it is a one-on function or not. What will you do? Just let me know. For any x belongs to R, fx exists because it is not a fraction. Have you got me? Is it a fraction? No, it is not a fraction. So there is no condition. That means domain is R. Domain of the function is R. So what will I write? Write down for any x1 belongs to domain, x2 belongs to domain. Okay, if x1 is equal to if x2, if and only if, okay, 2x1 minus 1 whole square is equal to 2x2 minus 1 whole square, right? Now from here we see 2x1 minus 1 is equal to plus minus 2x2 minus 1. Okay, and from here what we are getting? From here what we are getting? We are getting two parts. Number one is a plus, that is 2x1 minus 1 is equal to 2x2 minus 1. Minus 1 will be omitted, that is 2x1 equals to 2x2, x1 equals to x2. But we have got another value, that is 2x1 minus 1 minus 2x2 minus 1. Have you seen? Here plus sign was taken, but here minus sign has been taken because it is plus or minus. Okay, so it is plus sign has been taken here. This is the plus sign has been taken here, and here it is the minus sign. Okay, now we calculate. You see, 2x1 minus 1 equals to minus 2x2 plus 1. Okay, so we are getting here 2x1 equals to minus 2x2 plus 2. That means, you see, we can divide all by 2. We are getting x1 equals to minus x2 plus 1. Now you see, it is the left hand side here. Here it is the left hand side x1 same, but our right hand sides are not same. Have you seen? Can you differentiate? Our right hand side is here x2 and here minus x2 plus 1, right? So we are not getting the same, is it?
Yes, sir.
That is not 1 for 1. So
It
here
is not a 1-1 function.
you are absolutely right. Fx is not a 1 1 function. Okay. So we have come to conclude of maths of one function. That is, we have come to know if the function is given like this, fx is like x square, fx is like x square plus 1, fx is like x square minus 1. Okay, this type of math. Okay, then fx is like x plus 1 whole square. If fx is given like x minus 1 whole square. They are not unknown functions, okay? As a square is given. Or it is that fx is equal to 1 by 3x minus 6 whole square. This type of math. They are not unknown function. Even we are getting, suppose fx is equal to this. It is also not a unknown function. Suppose x plus 1. It is also not a on absolute value. It has two values. One is positive and the other is negative. Okay. Okay, very good. Now I am going to do a math of absolute value sign. Absolute value. Suppose we have been given a math like, you see, like fx is equal to this. Is it a one-on function or not? This is the question. Okay, this is the question. Very good, not a matter. You write down for any x belongs to R. Okay, fx exists. Okay, therefore DOMEP is equal to R. Okay, because it is not a fraction, it is not a square root. That is, we will get an embargo. Okay, of finding the domain. If it is not a square root, if it's not a fraction, then the domain is R. Very easy and simple. Remember, for a square root and for a square sign. Okay, sorry, for a square root and for fraction, this type of. Here root x means what? Root over 2x plus 5. Here 1 by x means what? 1 by 2x plus 1. Example. So this type of math, okay, to determine the domain of this type of function, we have some conditions, okay? But as there is no square root, there is no fraction here, so we don't have any confusion to determine the domain. Their domain is always R. There the domain is always R. Anyway, write down for any x1 belongs to DOMEP, x2 belongs to DOMEP, f of x1 is equal to if and only if x1 plus 1 is equal to x2 plus 1. This is the absolute value sign. Okay, this is the absolute value sign. Now we have to know what is the absolute value sign. Okay, you see, absolute value sign, that is, this is the absolute value sign. Its value is x when x is greater than or equal to 0. Its value is minus x when x is less than 0. Absolute value sign of x has two values. One of them is x and the minus x. Do you know it? One day perhaps I showed you. Suppose you are going to find the value of this. Can you please let me? What is the value of absolute value of minus 3? Its value is 3. You know? and even its value is 3. Now the question may be arisen that how does it come? Okay, what is the proof? Okay, you see the proof. Suppose it is what we are getting here. This is what here. Suppose minus 3, and you let x equals to minus 3. The value of x has been let as by minus 3, and we see this minus 3 is less than 0. Minus 3 is less than 0. So that is absolute value of minus 3. If it is less than 0, then we have minus x. Minus x, what is the value of x? Minus 3. Minus 3. So it is 3. My absolute value of minus 3 is 3. This is the proof. Okay? You see, this minus 3 is less than 0. I wrote here, if it is less than 0, then minus x. Okay? Now, where we were like this x1 plus 1. Can you remember? x2 plus 1. Perhaps you have written.
Yes, sir. We were here.
Okay. Implies that x1 plus 1 is equal to plus minus x2 plus 1. Okay. If there is any absolute value, so it is to be, when you will omit that sign, you have to always get plus minus. Is the first condition. So that means we are getting here x1 plus 1 equals to x2 plus 1. And here we are getting x1 plus 1 minus x2 plus 1. Okay. So from here we get 1 will be omitted. That is x1 equals to x2. And here we are getting x1 plus 1 minus x2 minus 1. That is, we are getting x1 is equals to minus x2 minus 2. You see, they are not the same, right? So fx is not a one-on function. Fx is not a one-on function. So you did about 6 maths of determining whether the function is a one-on or not. Okay. Have you got it or not?
I have got it.
Okay. Onto function. Onto function. Okay. Suppose we are getting a function f a. This is a function. It means f of a is equal to b. What is the meaning of this? F of a equals to b. Have you got me? It means f of a equals to b. It will be called an onto function if it will be called write down an onto function if for every b belongs to b, there exists a belongs to a. That f of a equals to b, where b is range. Range means range of the function. Okay, now what is meant by this? Okay, but please listen to me. F of A equals to B. Now I am going to write down this. Can you please let me know in this question what is y? Y means range. Y equals to fx. You see, y equals to fx. So value of y is x square. So x square is the range. And this is x, it is the domain. A is domain, B is range. Okay? Okay, let us do some math, then you'll come to understand. Okay, you see, suppose a function is given fx equals to 2x plus 1. You have to determine whether it is an onto function or not. Very good. For onto function, you write down let. Every time you have to do it. Let y equals to fx is equal to 2x plus 1. When it is a math to determine whether it is an onto function or not, it is your first function to do like that, to let y as the function of x. Very good. From here we can write down y equals to 2x plus 1, right? And from this equation, you have to always determine the value of x. So we can write down 2x plus 1 is equal to y. That is 2x is equal to y minus 1. That is x is equals to y minus 1 by 2. We have got this value of x. So please pay attention. Important part, important math. Okay. So we have got x equals to this. Okay. Now you again go there. Here. Again, fx equals to 2x plus 1. Now let me know what is the value of x. Talk to me. What is the value of x? Y minus 1 by 2. Y minus 1 by 2. Have you got me? What is the value of x? Is as by y minus 1 by 2. Now you put here the value 2. What is the value of x? Y minus 1 by 2 plus 1. That means 2 will be omitted. So it is y minus 1 plus 1. We are getting y. You see, very interesting part. Putting the value of x, we have got y. And if it comes, if it happens, then it is an onto function. You see, if you put the value of x and if you get y, then it is an onto function. This is the basic formula. I repeat, putting the value of x, if we get y, then it is called an onto function. Write down. Therefore, fx is an onto function. Not onto, O-N-T-O, onto function. Not one to. Huh? Okay, let's do some other maths of onto function. Suppose we are given a math of onto function. Fx is equal to x by x minus 2. It is given. Now you have to determine whether the function is an onto function or not. Okay, so what will you do? Okay, that's good. Write down at first, let y equals to fx is equal to x by x minus 2. That means y is equal to x by x minus 2. Is it okay? So what I told you? I told you to determine the value of x. So we can write here x equals to xy minus 2y. Okay? That means x minus xy minus 2y. take x common, 1 minus y is equal to minus 2y. That is, x is equal to minus 2y by 1 minus y. From here, we can write down x equals to 2y by y minus 1. I mean, I have multiplied both the numerator and denominator by minus 1. Okay? So we have got the value of x. Value of x is here as by 2y by y minus 1. Okay? Are you there?
Yes, sir.
Okay. Now what will we do? We'll put the value of x. X equals to what? 2y by y minus 1. We'll put the value. Now, if we prove that it is equals to y, then our math is done. So very good. X is what? 2y by y minus 1. X is what? 2y by y minus 1 minus 2. Okay? I have just put the value of x in this function. Now you calculate. It is 2y by y minus 1 LCM y minus 1 2y by 2y plus 2. Is it? Then actually what is happening here? You see, it is 2y by y minus 1. It is 2y by y minus 1 into, it is y minus 1. And we see this will be omitted. So we are left with only 2 here, right? Now, if we go for calculating, this will be omitted. You see, this will be omitted, and 2 will be omitted. This 2 will be omitted, and we are left with y. What I told you, putting the value of x, if we get y, very interesting math, we never saw it, right? Putting the value of x, if we get y, then it is an onto function. Therefore, fx is an onto function. Okay? Talk to me. Suppose another function is given, again, fx equals to 2x minus 7 by 4x minus 2. Can you determine whether the function is an onto function or not? Okay, what will you do? Let me know. Let y equals to fx is equal to 2x minus 7, 4x minus 2, right? That means we are getting here y is equal to 2x minus 7, 4x minus 2. Okay? Now from here, you can write down 4xy minus 2y is equal to 2x minus 7. We have to find the value of x, that is 4xy minus 2x, 2y minus 7. From here, I will take common x, that means x 4y minus 2, 4y minus 2 is equal to 2y minus 7. So we are getting x is equal to 2y minus 7, 4y minus 2. Almost same. Have you seen? They are same. Okay. Now you put the value of x in the function. Write down. Therefore, f of what is the value of x? 2y minus 7y, 4y minus 2. 2y minus 7y, 4y minus 2. Okay. F of this is equal to f of this is equal to, you put the value 2 into this, that is 2y minus 7y, 4y minus 2, that is 2x minus 7 by 4x 4x minus 2. Okay, now please calculate it. Can you calculate? This is 4y minus 2, 2 into 2 4y minus 2 7s are 14 minus 7 4s are 28y minus minus plus 14. In the same way, it is 4y minus 2, 4 to the 8y minus 4 7 the 28, okay, minus 8y minus minus plus 4. Okay, so this is the math. What we are getting here, this omitted, and here this omitted. Which is equal to, you see, 4y minus 28y equals to what? Minus 24y. 24y by minus 2 into this 4y minus 4y minus 28 plus 4, that is minus 24. Now you see this omitted, minus 24 omitted. So we are left with y only. Is it? So can we tell that yes, therefore fx is an onto function. Okay, are you getting it?
Yes, sir.
Okay. Now I am giving you some proof that the given functions are both 1 1 and 1 2. Okay, so in one math you have to do the both proofs. You have to prove at first 1 1, then you have to prove that it is an 1 2. I am giving you some math. Number 1, fx is equal to 3 by x minus 1. Number 2, fx is equal to 2x by x minus 2. Number 3, fx is equal to 2x plus 3 by 2x minus 1. Number 4, fx is equal to 4x minus 9, 4x minus 9 by x minus 2. Okay, so I have given some math. Number 5, fx is equal to 2x plus 2 by x minus 1. Number 6, these maths have been given from the book. Number 6, write down fx is equal to, I have given you 6 maths.